So over the last little while, I've been doing some work to make it possible to use a SeedSigner together with the SeedKeeper product from Satochip. These are two fantastic open source projects, and I think they work better together. So basically in this video, I'll just be doing a bit of an overview of the ways you can use these two devices together. I'll be running through how to obtain and flash the software needed if you want to do it, as well as running through some hardware stuff if you want to add an integrated Smartcard reader to your SeedSigner. But let's get into it. And if you haven't already done so, hit subscribe, and that way you can stay in the loop for content I make to help you find your way in the crazy and often hostile environment that is cryptocurrency. So I'll be starting off on my GitHub, where I've forked SeedSigner and done some of this work, and we'll just run through these differences. And the first thing to say is that this functionality will work on any of the Raspberry Pi hardware that can run SeedSigner. So I actually have a Raspberry Pi 1B here, this is a Raspberry Pi 4, this is a 20W, and this is a Raspberry Pi 0. So in terms of differences from a stock SeedSigner, basically this fork allows us to use multiple smart card interfaces. So these two right here are just running a standard USB smart card reader. That one is for SIM sized smart cards, and that one can do SIM or full size ones. You could even just connect, any USB smart card reader. This one here is running a generic Phoenix type reader. They're really just a generic SIM reader. And the Pi 02W just here actually is an integrated NFC reader, which is just one of these PN532 NFC boards. So you've got lots of options for how you connect your smart card readers. And basically for all of these devices, we pretty much tell it how we want to interface with it using the settings menu, and we can choose the smart card interface that we want to use in there. All right, so functionality wise, first thing we can do is the saving and loading of seeds and passphrases. So for loading seeds, basically we just go into the seeds screen, and there's a new option here that says from SeedKeeper. So it'll search for the card. We'll just say A as the pin. The pin could be anything you want. So basically it's listing all the seeds on the card, because these cards can store multiple seeds, not just one. So these are all the different seeds that I have on here, and some of these are just a plain seed. So like this one here from a video that I did with the SeedSigner. So there we go, that's loaded there, and I can just finalize the seed like normal, or I can also optionally load a BIP39 passphrase, either together with the seed in one go or separately using any password on the SeedKeeper card. So I'll just say load passphrase. There we go, and I'll just use this one here called demo pass. So basically it's loading the passphrase off the card as well, so I can see now it's added the passphrase, and I can just say done. And there we go, so now that seed is on the SeedSigner just like any standard seed. And the important thing to say here is that the seed and the passphrase don't have to come off the same card. So if you want to split your seed and have multiple secure elements backing up different parts of your seed and passphrase, you can absolutely do that. And basically once the seed is loaded, it just functions like any other seed in the SeedSigner. So basically I can also go into here and choose backup seed, and now there is a new option that says to SeedKeeper. So I can click on that. I can just put a smart card in there. This is a different one. Whoop, let's try that again. There we go, and we'll just call this pin A, B, C, D, and just say tick, and saving seed, and there we go. So now this seed has been saved to this smart card. It's important to say that I don't think this takes the place of having your seed phrase backed up in something like Steel. However, I do think it's an excellent way to be able to securely keep a backup of your seed and your passphrase, especially if you have a long and complex passphrase, in a way that is secured by the smart card itself, and that allows you to load the smart card into the SeedKeeper in a way that retains complete privacy. Even if someone is standing looking right over your shoulder, they're not going to see any of the seed words or anything that would allow them to compromise your wallet. The other thing we can do is the saving and loading of multi-sig descriptors. Now let's use the little one. And look, I'll just use this one to show you that. So if we just go into Tools, go down to Smart Card Tools, go to SeedKeeper Functions, we can choose to load a multi-sig descriptor. And basically it will search the card. There we go, so we'll put in the pin. This one's AAAA as well. There we go. So there is the multi-sig descriptor. This is the same descriptor I used in this video over here, and we'll just click there to load it. And there we go. So that wallet descriptor is now loaded and is on our SeedSigner. And just like with the seeds, we can also go back to the Smart Card Tools menu, and we can also save multi-sig descriptors onto the smart card as well. Basically, we just give them a label. I'll just call this A, B, C, D, and say tick. And basically now it is saving the secrets to the smart card. And this one was actually already on there, so you can see that it was skipped. So the ability to save both wallet descriptors and seeds onto smart cards is really powerful, and it really can help you to mitigate some of the major challenges that go along with multi-sig when it comes to backups. One of the challenges with multi-sig, if you're not aware, is that you not only need to keep backups of each of your seed phrases, but you need to keep backups of all of the public keys for all of the signers that are part of the multi-sig wallets. Being able to save your secrets on smart cards like this makes it really easy to do something like have a 2 of 3 multi-sig wallet where each of your 3 backups has one of the recovery seeds and the full wallet descriptor for the entire wallet, all stored in a way that is secured by the hardware-based security on the smart card itself, making it really great to be something that you might be storing remotely off-site, that you might have multiple copies of, or that you might be traveling with, even just sticking it in an RFID blocking sleeve and sending it through the post. The other functionality is being able to save and load generic secrets onto the SeedKeeper cards. So basically just in this SeedKeeper menu, we can also say view secrets on card, and that'll show us all the different seeds, passphrases, multi-sig descriptor components, and so on. And I can, for example, just view this secret just as text once it's loaded on there. There we go. So that password is called test pass, and the password is just crypto guide. And I can also just press a button to show it as a QR that I could just scan with any phone or anything else. I can also just save arbitrary passwords to the card as well. So let's just say I want to call it A, B, C, D, just say tick. So the text could just be demo and tick. And basically now it's just saved that secret onto the smart card as well. One quick thing I will say is you can't currently delete secrets off these SeedKeeper cards, which is great in terms of having immutable information like your wallet descriptors, but it does mean that this is not going to replace something like your password manager. But if you try and store all of your passwords on here, they are probably not going to fit. The other thing we can do is initialize SatoChip cards with a SeedSigner. So these SatoChip cards are actually different from the SeedKeeper, and the SeedKeeper is just for storing secrets. The SatoChip card is actually a hardware signer, very similar to a tap signer or something like that. And look, we'll just set a pin for it just because it is brand new and hasn't had one set. There we go. So we'll say OK, and look, I'll just set this to be AAAA just to keep life simple. So the pin has been set. And basically, I just select import seed. I can choose one of the seeds that is on the SeedSigner, and basically now it's importing that secret onto the card. So pretty much now I can just use this card with something like Sparrow to access that seed. And I can also do things like securely enable 2FA on this card, which will show me a QR code that I then scan with my smartphone and use the smartphone companion app to approve transactions and that are made by the blind signer. Now, this is where things get really cool. So we can actually use our modified SeedSigner to flash the open source SatoChip Applets to blank Javacards. So for this one, I've actually just got my Pi 0 connected with a USB OTG cable to this full-sized reader here, and I've got a DIY card in there. So if I go into Tools, go into MicroSD card tools and go to DIY tools, we've got 3 options there: build, install, and uninstall. So if I go into install applet, you'll see by default it comes with the 3 official releases from the SatoChip GitHubs. We can also build applets. If you don't want to trust the official applets from SatoChip, you can also just select to build applets, which will actually build them on your SeedSigner itself, which will then allow you to flash them onto the smart cards. And the one thing I will say here is if you're trying to flash a THD89 based smart card like these little NFC tags here, you will need to build applets first because the stock applets won't work on that type of smart card. The build applets function does take ages, particularly on these Pi Zeros. It'll run for like 5 minutes. So I'll just install one of the stock ones. So let's say we want to make this into a SatoChip card. We just select that applet. And there we go. So that applet is installed, which means we can now use this smart card as a SatoChip or whatever applet we happen to install on there. We can also uninstall applets in the same way. Though this warning here is very important you understand, which is basically once you uninstall an applet off one of these smart cards, all the data that was associated with that applet on the smart card is wiped as well and is unrecoverable. Simply reinstalling the applet on the smart card will not bring your data back. So be very careful if you're uninstalling applets. And the last thing I'll show you isn't actually related to smart cards, it's just some MicroSD stuff. It lets us flash MicroSD cards with official SeedSigner images, verify freshly flashed MicroSD cards, and securely wipe MicroSD cards. So I'll just go back to this one here. So basically what we can do is go to Tools, go down to MicroSD, and we can choose that we want to flash an image. So basically this comes bundled with the official releases for SeedSigner OS for all the different Raspberry Pi variants. So if I say I want to flash an image for a Raspberry Pi 0, I can just select that one. Basically then I have to insert the MicroSD card that's going to be flashed. So I'll just remove that one there and stick that one in. This will be the one for Pi 0, and then say continue, and basically that is now flashing the MicroSD with the stock SeedSigner. And there we go, so it's done, and we can also just say we want to verify that it was flashed correctly, so it'll just read it back, and there we go. So basically it's telling us that this has been flashed and matches the checksum. So if I say continue, so if I pull that MicroSD card out and stick it in my Pi 0 here, I'll take the one that has the Smartcard image on it and just stick that freshly flashed one in there and turn it on. We have a stock image of SeedSigner that we flashed using this other SeedSigner. So that's really nice. And if, on the other hand, we want to securely wipe the SeedSigner microSD card and remove all traces that we were using it for this, we can go to microSD card and we can wipe it with zeros for either 64 megabytes, which will cover a stock SeedSigner image, 256 meg, which will cover one of these images, or the whole disk. That will take a long time. We can wipe that either with zeros or with random data. So if I just say I want to flash that with 64 meg of random data and say OK, that'll actually just blow away the first 64 meg of that microSD, which now means that if we try and restart this, it will no longer boot at all. Another handy tool to have in your toolkit. And the last thing I'll mention in terms of flashing both Javacards and microSD images is that the images that you can flash are just on the microSD itself. So if you go into the Javacard cap folder, for example, you'll see all of the different cap files that you can flash onto the Javacards, and you could also just stick your own cap files in there if you want. You can use this just as a general applet flasher. Likewise, in microSD images, you'll see the images that are available to flash onto microSD cards. And again, you can just stick your own images in there. So let's just talk about getting and running this software yourself. This is all on my GitHub right now. So essentially what you're going to want to do is go onto the releases page and just go to the latest release. You'll see a couple of things. If you scroll down, you will see the images that you can just download and flash in exactly the same way that you would with a normal image. And what I've got here is the images with their checksums. So rather than messing around with things like GPG keys, basically what I've done is just made a Bitcoin message, which is this text here in between the lines. I've got a signature for that message, and I'm verifying against my tip address. So you can do that using the Bitcoin wallet of your choice, or there's a wide array of online tools where you can just pretty much stick a Bitcoin address in, stick a message in, and you can verify that the signature that has been provided was generated by someone who controlled the private keys for that address. And basically what that allows you to do is know that these SHA-256 sums here are the ones that I have distributed. You can find that tip address in a range of my videos on my Reddit page and things like that. And the other important thing to say is that these software releases are all built using SeedSigner OS. So the builds are reproducible. You head over to my fork of SeedSigner OS and basically just follow the instructions there. They're pretty much the same as the stock one, except it is pointing to my repository, and you'll see here it's using the app branch for beta 1 as well as having the additional Smartcard argument. And essentially if you run this on your system and build it with Docker, you will end up with a binary file, the flash, that has the same SHA-256 sum of the ones that I'm distributing on my website here. I do intend to also add images for the Pi 2 and Pi 4, but just need to sort out some build route related stuff for the Pi 4 in particular. The other thing to say in terms of all of this using SeedSigner OS builds is you don't actually need to keep the micro SD card in while you're using your SeedSigner. So if you are feeling paranoid, basically as soon as your SeedSigner has booted, you can remove the micro SD card and still use all of the standard micro SD functionality. The one thing that you will need the micro SD card in the SeedSigner for is building and flashing of applets onto the Javacards. So using the Javacards to load seeds, wallet descriptors, or whatever, that all works fine with the SD card removed, but the SD card does need to be in there if you're trying to manage the applets on the card or build them from source. So let's look at the hardware. Now, if you just have a standard SeedSigner just with a standard case, you can just connect a USB-based Smartcard reader into the data port, which is the one in the middle. You can do that either using a standard micro USB OTG cable, or you can also do it with these little USB OTG adapters here, which are really nice with this small SIM based reader. And if you have a nice micro USB cable with a small plug on it, you can even squeeze that in just side by side there, and that kind of just works. Really nice solution. And exactly the same thing is true for these Phoenix based SIM readers. They just plug straight in there into the data port. Though the important thing to say is these standard smart card readers can also just be easily plugged into a computer and just used to access the data on your SeedKeeper card that way. Whereas these Phoenix based ones really are an absolute nightmare to get working in Windows, and honestly not much better to get working in Linux. These standard readers are also faster than the Phoenix based ones, so unless you're like extremely price sensitive or can't source these standard smart card readers, these are really the ones you want. You can pick the SIM sized reader along with blank SIM compatible smart cards just off the SatoChip web store, or you can just sort of pick up these standard sort of USB smart card readers from Amazon, AliExpress, or wherever. And now we'll talk about the integrated NFC reader. So there's actually two different ways we can do this, and I'll use these two different devices to show you. So I'll just pull them apart. So the important thing to know is that this PN532 connects using the I2C bus on the Raspberry Pi. So pretty much it's connecting using these 4 pins here on the Raspberry Pi pin header. And there's two ways you can get at this. The first thing is if you don't mind soldering, or maybe you're getting a Raspberry Pi without headers on it, you'll notice this one is actually missing those 4 pins. And what I've done here is actually bring these 4 I2C pins out the bottom and actually just put a right angle pin header on here, which brings it out the bottom of the board, which makes it nice and easy and compact to sort of loop around and send out to our reader. And basically this one here uses a case like this, and I've got a link to my printables website. Put it in the case. We just start off with the camera going in there first. It just sort of clips. The camera just sort of goes into its little hole. This all just goes in there just like normal, except when we're putting it in, we want to feed our wires through this hole down here before we snap everything else into place. So basically those wires will just all go in like that. Making sure you remember which is connected to which pin. We angle all the sockets and things down. Slide them in first, and then this basically just clicks down into the container like that, and we've got heaps of length then to be able to connect. In this instance I've made green, ground and yellow VCC. And blue is SDA and brown is SCL. So basically we can just sort of connect that in. We can just then slide this down in there like that, and pretty much then this just clips on there just like a lid. It's sort of a press fit, and you can just put some glue or something on to hold that in place, and then our screen just goes on top. But we'll leave that lid off for the moment just because it's nice to be able to see what's going on in there. So we'll put our MicroSD card back in, we'll power it on, and we can see that has lit up, which is good. So that little light is lit up in there, which means we're booting, and we'll just give it a sec. There we go, SeedSigner. So what we're going to do is just to make sure this is working correctly, so we can see it's lit up, so it's getting power, and then we're going to go into settings, and we're going to say test NFC scan. Basically what this is going to do is just test the NFC reader. So there we go, we can actually see that that worked. And if this is not wired in correctly, or not connected at all, you'll actually see an error message in here saying it can't detect the reader or something like that. So there we go, so that is good, and we can actually just stick the lid on that, and that is one way to do it. Now alternatively, you might not like the idea of messing with your pins, or they might be pre-soldered, and a really easy workaround for that is these sort of pin header expanders you can get off Amazon, AliExpress for a couple of bucks. They basically just sit on top of your existing GPIO pins and basically just give you an option to be able to access them all out the side and still be able to stick a display hat on top. So they're very nice. And basically I've got a 3D printed case here that I designed that'll work with that kind of pin header as well as one of the spy cams on top. It is a lot taller than the other option just because it has to fit the sort of pin header splitter in there, but it's still actually not too bad. So pretty much for this one, what we're going to do is we're going to put it together like a normal Raspberry Pi. So we just stick our 0 cam in there, shove that all down in there first, and just click that into place. So just make sure the camera is in the middle of the hole, not getting squashed, and then we can just sort of push the PCB down on the side, and that'll click, and that is in place. So now we have our 0 cam in there and our PCB. So what we'll do now is we've got our pin header, and I actually just stuck the wires on this one. They're similar colors to before, except in this instance the 5 volts, I've made that grey, but it's still using the same 4 pins. And this case actually has a bit of extra real estate up there to be able to allow these full length headers to be able to squeeze in there. So basically what we're going to do is just sort of going to move these cables just out of the road, and we're going to sort of squeeze that in there. It just fits, and then we push that down on top of the existing pin header. So that is now in, and we now feed these wires in through the little gap that exists between the camera ribbon and the PCB. There is enough space for them to fit. So there's also plenty of real estate in here, so you don't need to use little short cables like I've done if you prefer to have something nice and long to work with. So we'll just pass them through the hole. There we go. And you'll actually see these ones have caught on this little support here that for the screen, so we'll just pop them off there and then squeeze them down. There's just enough length to be able to see what we're doing in terms of wiring it all up right down here. So basically we'll do what we did before, so we'll put ground to ground, VCC to VCC. There we go. Oop, hang on. So I just noticed that on that one I managed to reverse the ground and VCC. Don't do that, you don't want to blow your little board up. There we go. And basically for this design, the easiest way to get it on is actually to pull these cables up a little bit as you slide it in, just to keep them clear of the camera connector, and that just goes down like that. So now we just pop our little display hat back on. Stick our micro SD card in, and we power it up. So we can see the little LED is happy and lit up through there. There we go. And what we'll do is we'll just do the same thing we did before, go into settings, go down to test NFC scan, and we can just check that it detects our smart card, which it did. So that's good, it tells us we've got this connected correctly. So now if I go into smart card interfaces, change it to the PN532, I should be able to just load a seed from the SeedKeeper. I'll just put that on there, say load from SeedKeeper. And if you get a pin prompt, basically it tells you it's connected to the card. There we go. So basically that is all working, so we can stick our little lid on there, which has a little groove to help hold the card, and we can just sort of stick a little bit of glue on there just to hold it in place. Now, one issue with these cheap NFC interfaces is quality control. And these are all just sort of Chinese clones, which is why you can get them for like $5 a piece. And honestly, how well a given card works seems to come down to the luck of the draw. So basically, this one that's in here right now, for example, actually doesn't work at all for Smartcard. I can just sort of stick it on there, and it will never actually find it or work reliably with it. Like occasionally it might find the card if I position it just right, but it's not going to be reliable. It's going to be very frustrating. Though the thing to note here is that it does still work well enough just to work for like a normal, NFC tag for people who are just doing basic NFC stuff, but it's not reliable enough to actually do a proper smart card sort of interaction over it. And despite the fact that the printing on the PCB on this middle one looks the best and it looks the best quality, it's the one that actually doesn't work. These two obvious clones on the sides actually work perfectly fine. Now, the important thing to say with these PN532 NFC reader boards is that the placement of them can have a dramatic effect on how well they work, including if they work at all. That's why both of these 3D printed designs that I've got essentially have the reader just sticking out the side to give the NFC reader the best chance of working and getting minimal interference from the PCB running the SeedSigner. And this interference issue is really well illustrated with this Raspberry Pi 4. So I've actually just taken the plastic cover off it, and this one actually just has a WaveShare PN532 hat that just sits nicely on the Raspberry Pi 4. But you'll notice the screen is actually overhanging the NFC reader. So what you'll notice is, firstly, it does scan Smartcards just fine. However, if I go into the Seeds menu, go to Load from a SeedKeeper card, there we go. So it's found the card pin. So if I just say A and press this bottom button here, it'll actually verify the pin and list seeds, and that's fine. But the really interesting thing with this is if I press either of these top two buttons, it will immediately disconnect from the card. So if I press this middle one here, you'll see it'll just immediately throw an error and say transaction failed. So this can be incredibly confusing if you have managed to do something like use a PC or another device to set a pin on this that requires you to press this middle button, and you'll never actually be able to unlock it using this reader with the screen overhanging the NFC reader like that. So yeah, definitely something to be aware of in terms of just how sensitive some of this NFC stuff can be to interference, and also just a warning for those who might think this WaveShare NFC hat looks like a pretty nice and easy solution compared to those other cheap ones. You know, it would be great, but if you do want to use it, you're gonna have to do something like rearrange the screen to be like hanging off to the side or something huge like that. But anyway, there you go. So there you go. Like a lot of great stuff that happens in the open source space, this is really a case of someone like myself wanting to, you know, scratch their own itch and to build the tools that they want to use to be able to securely self-custody their Bitcoin. And it's important to say this is not an official release from the SeedSigner team, but rather a proof of concept that I put together, and I'm keen to see what other people might find useful, valuable, or ways that we can improve this in the future. It's definitely at a level now where I think it can be considered beta software. It's still going to have some bugs in there here or there, but definitely something that I think is ready for folk to have a play with and to just let me know how it's going for you. I'm keen to see how folk might use this and ways we can help grow this, not only for SeedSigner but for other hardware projects as well. If you've got any questions about how this works, definitely just drop something in the comments section. I do my best to reply to all of them. I also do tend to hang out on the SeedSigner Telegram group. If you want to know more about what's going on under the hood, it's all on GitHub. The manual build page has a good description of all the different software and packages that are being used. And if you want to sort of contribute to the sort of technical discussion around this, the best place to do that is on the SeedSigner official issue tracker under the issue for adding Smartcard functionality to the SeedSigner. Best of luck and stay safe. Thanks for watching, I hope that was helpful. Hit like if you think that other people would find this video useful, and hit subscribe if you'd like to be kept in the loop about future content I make that helps people stay safe in the crypto space and to recover if they get into trouble. If you have any questions about this video or a topic that you'd like me to cover, just leave a reply.